someone who maybe doesn't, would have a hard time evangelizing, but they do have a burden for people to share the gospel. Could they certainly fill more of a technical role, like almost like we're training for right now?
So,
less of.
if you look at what Paul wrote, 1 Corinthians chapter 6, now we're getting straight theology. So, 1 Corinthians chapter 6, we have gifts. And gifts were bestowed for what reason?
To contribute to the body.
Okay, so does that mean there are strengths? So in strengths, there's also what? Weaknesses. So maybe I have the gift of evangelism. Okay, maybe I have the gift of teaching, whatever. So I use those gifts to enhance your gifts or your weaknesses. Okay, but then you have gifts that I can learn from. Oh man, did you see Corbin do that? So I'm going to learn from Corbin, and I'm going to grow. You know, I watch people like my dad. My dad is a giver. Oh my gracious. I won't go into amounts, but to mission organizations, he is a huge giver. And it's like, wow. He never asks for any recognition. Ever. Like, he'll send a check that says, don't tell anyone. To lots of mission organizations. Why? Because he just loves the fact that he has a privilege to give. And I watch that and I learn, and it's like, wow. Now, do I have that ability that he has? Not at all. But I'm learning from it. And that's the point of 1 Corinthians chapter 6. Each one has a gift. So someone may be a gift of evangelism. Great. Then when you need to learn how to evangelize, maybe you're not strong at it, who do you go to? Person who has the gift. Somebody has the gift of teaching, who do you go to? Someone that their strength of teaching can help you in presenting a lesson. Make sense?
Yeah. And
that's the whole point of what Paul's talking about. The whole body sticks together, but where there's strengths, there's also weaknesses that we can learn and grow from each other. So yeah. Makes sense?
Yeah. Okay, thanks.
All right, how about fuel systems? All right, let's hop into it. Yeah, everyone got a syllabus? Mine is riding. All right, so I already hit this one. If those of you who really want to listen to my voice later, you're welcome to. I'm going to start off today a little different direction here. I'm going to hit this for a review, and then we're going to hop into a video. We're talking about fuels. Fuels, okay? I showed this chart on Tuesday. That seems like a week ago, doesn't it? Showed this chart. It's in your book on page 14-8. Turbine fuels. Turbine fuel has a higher or lower BTUs than avgas. Higher per volume. Right, okay. So, when we're looking at this, what's the bottom of the chart? Okay, so they get crude oil, boom, they're pumping it out, or maybe they banned it again, who knows. But anyway, we get this crude oil, and what happens here? So the sludge gets part of our house, if you want to heat with that, or if you want to cover asphalt, tarmacs with it. We get roads and roofing, tar. That's the sludge. Then we get the next bare bones sludge here, gets sold to the ships. And then we get lubricating oil, waxes, polishes, diesel fuel, and then we get to jet fuel. What's the real key difference here?
Volatility.
Say what?
Volatility.
Volatility. Okay, we're getting to a more pure kerosene here. Okay, we have more additives in, diesel fuels. That's why it stinks. And then Jet A just smells so sweet, right? So we get Jet A here, and then we're getting to avgas, and then finally unleaded gasoline and other chemicals. Okay, so characteristics significantly different than avgas: higher viscosity, low volatility, higher boiling point, more carbon, higher sulfur content, additives in fuel to control oxidation, ice, microbial, and bacterial growth. Why do contaminants grow in jet fuel more than avgas? Why is that? Yes, Steve?
Viscosity. Second. But
Good.
viscosity, yeah, it can suspend.
What about the viscosity though?
It's less viscous, so it can suspend bacteria growth.
Good. What's the long-term problem with that?
It doesn't store well, so.
Okay, and then what?
Fuel systems.
Fuel systems. Now our filters, our lines, fuel tanks begin to break down. Those of you are going to have opportunity even starting today pulling the King Air fuel tanks. Start to get this film inside of it, begins to break down the rubber. Okay? So that's why we have to add additives to it. Is it okay to run avgas in a turbine engine most of the time? Most of the turbine engines can actually take avgas. Now there's a set period that you can run it, okay? But long term to run it, it's not good, but most of the engines will take avgas. But avgas will not, an recipient engine will not allow you to run turbine fuel, okay? So when does, one more question, I want to think like a mechanic for a second. So when will microbial growth accelerate? When would it accelerate? Say what?
When it's warm out.
When it's warm out. So if we take the beach jet is a prime example. Right now, we fuel it up outside and then we stick it in the warm hangar. It is highly probable you're going to get bacterial growth. That's why they tell you sump it, almost instantaneously, sump it. Sump it the very next morning if you can, get it cleaned out, okay? You want to make sure you get water because it's the most common contamination.
That bacterial growth will be at the bottom.
Sometimes, but the water is the first thing. You want to get the water out, condensation, anything like that. But if you can treat it, going from cold to hot like that, it will accelerate the bacterial growth. Yep. And that's why a lot of places like GRR, if you buy fuel, it's going to have Prist in it already, the additives. All your trucks have them already in it,
What? Oh, Chris?
or whatever
We used to
treat.
straight and we would sump them, we'd sump our tanks every morning though.
Yeah.
So,
All right. All right. Let's see what jet fuel does. I really enjoy this video. Oh, we don't get it now. Oh, thank you so much.
Sign in to confirm you're not a bot.
It's funny it plays on my computer.
Anybody else not be able to access the maintenance publication library today? Not working.
I'm gonna access the network.
The manuals? Yeah. I can use today. Okay.
I'm testing this jet engine on 4 different fuels: jet fuel, diesel, biodiesel, and hydrodiesel to see which one makes the
This guy has
fuel, diesel, biodiesel, and hydrodiesel to see which one makes the most power. I'm using this jet engine in some upcoming episodes and I'm doing some experimentation. This thing sounds absolutely insane, so I just had to share my testing with everybody. First thing I have to do, build a jet dyno. I'm gonna show you the 4 fuels I'm gonna be using for these runs. And funny enough, projects like this is not what I acquired the water jet for, but after some experimentation, realizing its precision, I decided to use it for projects like this to give people ideas on what types of equipment that they can use to make their ideas come to life. And I think it came out pretty amazing. Oh no. Well, I could have got, there's definitely ice in there. That's really interesting. All right, let me try this again. Here we go, all in. Boom, 5,000 on the dot. That's the coolest looking fuel I've ever seen. This fuel always trips me out whenever I see it. It just looks like it won't burn. Just doesn't make sense in my mind. There's actually ice, but I did get the summer version of the diesel, but I'm glad I did because now this proves that 20% water. That's really cool. My hydro diesel has been sitting outside for over a year. I got it all defrosted. I got all my fuels set up, ready to go. The only thing I have left to do is add oil to all of my fuels for my turbine. Okay, I got everything all set up. The ECU, the fuel pump, and the jet engine. Here we go. This is going to be Jet A fuel on the dyno. All right, so that was it for the jet fuel. It used about 1,000 milliliters, more or less. So now on to the diesel. All right, let's go. Here goes the jet dyno run on diesel fuel this time. Here we go. Okay, one thing I did notice about that run that was a little bit different. With the jet fuel, when I would idle it down, it would reduce the RPM really quickly. It was pretty responsive. And with the diesel fuel, I noticed when I went from full throttle to idle, it took about 2 seconds for it to actually start ramping down. So I don't know why that is. Maybe the fuel, different consistency or different energy content. And it used about the same amount of fuel. But other than that, the only thing I saw different was the way it smelled and how it looked when I shut the engine off. Let's move on to the biodiesel. Man, this sucker's heavy. I'm scared I'm gonna drop it. This right here is why a FOD screen is really important here at the lower altitudes. Here we go again. This time, biodiesel. more smoky than the diesel. That was biodiesel. It sounded slightly different, and it seems to have burned less fuel than the diesel. Just a little bit less. I did the same run, which was warm it up, do 20 seconds full throttle, 20 seconds at idle, 20 seconds at full throttle, cool down, and then shut it off. I did the exact same sequence with my timer, and it definitely burned less fuel. Now moving on to what I've been anticipating since I started this video, which is hydrodiesel. It's 80% diesel, 20% water, and let's see if the jet engine is gonna burn it. That's the
All right, takeaways. Takeaways that you had from different types of fuel as our modern generation, we're obviously always, trying to come up with better ways to burn. Takeaways? More effective ways, yep.
What we got works.
Well, what did you notice about it?
EJ performed very well.
In what ways?
As far as thrust.
Okay, better thrust?
Cooler.
Yeah, it was a lot cooler, even on startups. What does that mean long-term? So, yeah. So if we're getting, a recip engine would get roughly 1,700 to 2,200 hours between overhauls. Jet engines are running almost 4,000 with the ability to extend if you have electronic basically data. So you're recording data every startup on your temps. And as long as your temps stay below certain numbers, I've seen them go over 5,000 hours, not on an air tractor, sorry, but on like Pilatuses and so forth, you'll see them go over 5,000 hours as long as you can present that your temperatures are staying down. Because it means that, hey, everything's moving freely, because as over time, as things start to get tighter or wear out, it begins to get higher temps to get the same amount of thrust. Yes, ma'am?
Where do you find the temperature range for those engines?
POH on your startups, or the beach jet has a maintenance log that I always look at when I'm starting it. And my numbers for the beach jet are like 640, 650, 640 on inlet temps. What was your tractors? On startups, somewhere. Yeah, 680s to 700, somewhere. That would be real close. You don't want to hit 680, yeah.
So hydrodiesel is just emulsified diesel and
80%, yeah, diesel, and then 20%.
does that get more thrust than the normal diesel?
I don't know. But we noticed what happened with our RPMs when we started mixing it up.
They went down.
We significantly lost RPMs, and then we also lost our thrust, yeah.
They gave the ratio of 80 to 20 diesel to water. There's gotta be other additives in it.
Oh, I'm sure.
Yeah, okay.
But they don't tell us that, otherwise we would sell it ourselves.
What does the water do for us?
It's pretty much everywhere, so it saves us money. Yep.
Don't we like want to avoid water and fuels contamination?
You would think so. But hey, right now they're in the middle of making, hydrogen, everything, engines, and so.
How do they deal with just additives? They deal with microbes.
Yeah, exactly. Are they filtering it, or are we having to put more additives like Prist and contaminants in it? Yeah.
It's okay for turbine, but like for reciprocating engines, it's worse then? Because like I thought on reciprocating we were like sumping so we get the water out.
We have to sump to get the water out. Yeah, it will not we can't get it to atomize in the airstream and then ignite. That would be amazing. I guess if we had a hot enough spark, we could get it to ignite. But yeah, that's exactly right. They're trying to get it to atomize, and they're gonna have to use a hotter ignition, I guess, to make it ignite eventually.
So my question with why are we using water wasn't so much why are we using water over something else, it's why are we using anything else? Why are we just using it so we have more volume? Why can't we not just use a lesser volume?
I think that the goal of using hydrogen or even water eventually is because it's a renewable resource that we have. Now, it's also comes back to a biblical perspective. Is the world 8,000 years old, or is it millions and millions of years old? One of those ideas where, okay, are we going to end up using all the petroleum? From a maintenance perspective, is Jet A was cleaner. You had better thrust, and you had, I think, even smoother engine operation.
What was the reason for not going to higher RPMs with the other ones? Just 'cause they couldn't
They
make it?
did. They just didn't perform.
Okay.
Yeah. And same thing. Not that I want you to try this. The same thing will happen in your car if, like, for example, my Acura is well stated on the dash 93 only, but I do not give that thing 93 ever. Okay, I realize I'm breaking all kinds of like rules and regs. Thank you. But if they want to pay the 93, fine, they can pay for it. It's said that I will get better fuel economy, better mileage on the 93. Probable. But I'm not here to argue that because I'm sticking with 87. Okay? Same thing happens where I'm sure if I was to try it, it would work. Okay? But then I was telling you my Corvette, it would not run on 87. It would not. I tried. It would not run. It didn't even like 93, so I had to use another substitute, which we will not say for other reasons, that worked a lot better. And it seemed to get really good mileage. I would get about 7 or 8 with 9 on the interstate miles to the gallon. So 87 was pushing about 87 or even 90 would push about, or is it 89? Push somewhere around 6 miles to the gallon. And that was very, very obvious. The fact that I had to stop every few miles to fill up. So, all right, take a break. Come back at 5 after. We're gonna hop right into a Kahoot. A Kahoot. If you were not here Tuesday, you need to figure out Kahoots. It's not graded, so just relax.
Wait, what's not great?
Kahoot. Take a 10-minute break. Come back at 5 after. Oh, sure. You know, how did you get so smart?
This is like the players and stuff last 4 years. That's how like every class did reviews. Yeah, just go to kahoot.it. That's easier than grading.
All right, log in using the gamepad or your little scan code. There you go. All right. It's gonna kick some of you out. It's saying it's only gonna let me do 10 today. It didn't let me do 30 the other day. Well, there we go. It's funny because this is just the intro. It's so funny. I don't know, it's because it's probably not an actual quiz, but it's only gonna let me do that. Hey, this is not a quiz. Alright, we're gonna try it like this, and then we can come back and do it again. Alright, so then once it opens up, you're gonna have 4 selections here. What's the pipe? All right, Carter killed it. Roll Tide, where you at? Anyway, the way we get points is how fast you do it, and then if you get it right or not. Okay, so it's out of 1,000, and so each second takes away points off 1,000. All right. All right. Next question, Smats. C414 is currently here with the condition. Whoa! Yeah, he's not working on our airplane. All right. Roll Tide moved up in it. Okay, all right. All right, when would someone need to hand prop an aircraft? Not the first one. It's circle. Okay, some of you are like, man, that logic was way off. Okay. Oh, 400 is what type of aircraft? Okay, hey, good job. Christian, back there, really good job on that one. You scared me a second ago. All right, last question. Carter moved up again. All right, last question. Everybody ready? All right. Okay. Hey, sorry that I didn't realize because it's not an actual quiz, it's just a practice that they only limited us to 10. But we'll fix that for tomorrow. All right. So let's do the little dance. Everybody ready to watch the little, what do they call it, the podium? That's right. Podium. All right. All right, Jedi Master over there. Is that you? Jedi, okay, good. All right, T-Swift, still a little weird. All right, so anyway, that's how Kahoot works. And then you'll be able to review them once you do it. Just so you know, none of the quizzes have anything to do with this intro one. Zero. Zilch. It's only for you to be able to see it, okay? All right, make sense? We'll wait for Joe to stop laughing. All right, before I hop into the next lecture, I want you to just be able to see this screen here. Turbine engine fuels retains water more readily than avgas, more readily dissolved into the fuel. Entrained in fuel due to higher viscosity allows microbes to assemble and grow and live. Okay, that's why we have to put a treatment in it. Downside is that it can clog and degrade fuel. All right, this is your groups where we'll be starting. It's also posted in the back, right behind Mr. Welch there, if you do not know what group you're in. These are rotating groups, okay? What does that mean? So let's pick on Amanda and Samuel, okay? Their group is on a gasculator or strainer. They're probably, I always have to preface myself, highly probable that they're going to finish before these folks finish on their fuel tank. Highly probable. Okay? I said you will finish, and then last year, or 2 years ago, someone shattered the gasculator and realized, oh, you're not going to finish. Okay? So, never cease to amaze me. So, anyway, they will take the gasculator apart, inspect it, reassemble it, install it, and safety wire it. And then I will sign you off, a signature on it. You do have to get signed off, and then when you do, then you'll move over to a valve. Okay, the valve, until one of these groups gets done, but more than likely, these two sections are going to finish both of these projects before they do. And then they'll rotate off, so you'll rotate as there's availability. Okay, what does that mean? The King Air is going to take the longest. Okay, it's just going to take longer. But I don't have a King Air for everyone to hop in on. Okay, and then I don't have an Apache for everyone to hop in on. Okay, the way the lab reads is that you just remove a fuel tank, you test it, and reinstall it. Okay, all right. The way that we test fuel tanks is actually in the back of AC 4313 2B. Anybody ever looked in the back of AC 4313? You have two sections, 1B and then 2B. The back of it will tell you that you're supposed to pressurize a fuel tank to about 2 psi. No more than 2 psi. Everybody got me? Okay? So what we're going to do is, did I get everybody's name? Did I leave somebody out? Why do I have a blank? I guess I have an extra if one of these groups finish first. That must be what I'm doing here. All right. I'll come back to this group in just a minute, but I need to hop into fuel tank types real quick. All right, everybody got their group? All right, so let's talk about gravity fuel feed system or feed fuel system. Gravity feed fuel system tank spaces must be interconnected if the engine is fed from more than one tank at a time. If you're not going to understand some of this, just wait till the pictures. For those of you who are like myself that are visual learners, just hold on for one slide, okay? Just take this in, try to understand it, and then when you see the picture, it'll make more sense. Gravity feed fuel system space above the liquid is vented to maintain atmospheric pressure on the fuel as the tank empties. A gravity fuel feed, or feed fuel system, must be able to flow 150% of takeoff fuel flow. Now, this is probably not the standard anymore. The FAA has kind of gone to the engineering, if you could prove. But originally, when they did a gravity feed fuel system, I'm trying to think, even the 172s, where's Kurt? Even all of our new 172s are all fuel pump systems. Do they even make a 172 that's carbureted off the assembly line anymore? I don't think so. I don't know anyone who would order that. Because fuel injected is so much more efficient. So, yep.
How do they pick 150% compared to 120?
Ooh, because it's gravity. So when we get to pump system, it goes to 125. That's just what the standard is. Why do they pick 55 instead of 45 for every speed limit? That's what they determined was probably the best speed. Okay, safe speed. So this is a safe flow for gravity fuel feed system. Okay, so
What attitudes?
well, it depends on what aircraft, but it's supposed to be in all attitudes certified for that aircraft. So if it does not have an A in front of the aircraft, is it certified for aerobatics? No. So if you're in a hammerhead and you lose fuel pressure, you're supposed to have 150%. Yes.
You're not supposed to be.
You're not supposed to be doing a hammerhead. Okay. Makes sense. It is the simplest of all fuel systems. FAA question says, what precaution must be observed if a gravity feed fuel system is permitted to supply fuel to an engine from more than one tank at a time? What precautions must be observed? And the answer is the tank airspaces must be interconnected. Tank spaces must be interconnected. What does that mean? Somebody's getting ready to ask me that question? No problem. I'll give it to you. So, these are interconnected here. What's this referred to as? My pilots? What's this also referred to? Cross vent. Cross vent. A cross vent. So, here's our fuel tank. What is this thingy here? Not a gascolator. What'd you say? Sump. A drain valve or a sump. We use the word sump because it sounds better than drain valve. I don't know why we do it. This is called a finger inlet screen. Okay, finger inlet screen goes like this into the fuel tank. Now notice it's a large mesh. Everybody see that? Very, very large. So basically, what is that protecting against? Basically, the rubber bladder coming apart. Okay? Hopefully, if the rubber bladder is starting to come apart, at some point somebody notices before this thing gets fully covered. Okay? But that's a finger inlet screen. Now we have down to the fuel selector to the strainer or gasculator. Why do we use two different names? That's exactly right, Clayton. They want to complicate your life, okay? It's two different generations. One didn't like gasculator, so they wanted to call it a strainer, okay? And so that's why we have, yeah, maybe they hate us. All right. So then we go over to the primer. 4 cylinders there. Most of the time, you don't prime all 4 cylinders. Most of the time, it goes to 1 or 2. Okay, but whatever. We'll put 4. And then down to the carburetor. Carburetor's hooked to the engine. Okay, well, you're not supposed to go beyond that because we're not talking about power plant. Yes.
Am I getting more pressure from my fuel system when I'm doing cross feed, or is it regulated?
It's gravity, so you shouldn't be. You should have the same fuel pressure. You get more fuel pressure if you have more fuel.
Yep.
Right? Because you have more volume to push on the little bitty lines, right? So, yes.
So you said that there has to be cross vents?
Cross-vented, yes.
Cross vented, okay. Is that the same thing as in the previous slide, being interconnected? The previous slide, tank spaces must be interconnected if the engine is fed from more than one tank at a time.
You're talking about multi-engine there. If we're running from more than one tank at a time. This specifically cross-venting is if one tank,
Yeah,
basically we had to get air to equalize between the two tanks.
yeah, gotcha.
Okay, now, as I said the other day, just give me a sec, 1 sec, okay? The cap here is going to be vented, and then you've got a vent here, okay? Now, updated systems will have a vent on this cap, a vent on this cap, and it will be vented here, okay? In case any of those get plugged, all right? Old style over here, you had a vent, and you had it interconnected here, and then the cap over here was vented, yep. All right, yes, sir, what was your question?
I have 2 questions. I'm assuming, is just not adding another vent to the other tank, does that save us more weight than adding a venting cross vent?
Some aircraft do add multiple vents. The Pipers add a vent here, and a vent here, a vent here, and a vent here, and an interconnected vent. Or sometimes they don't even add an interconnected vent.
Okay, so if you have vents for each tank, you don't need an interconnecting vent?
They want you to interconnect the vents because of dirt, or maybe if you flew through some kind of, hazardous material, and your exterior vents got clogged. The hope is that maybe one of these did not get clogged.
Okay.
So sometimes,
Can you also go back to the previous slide?
the Beechjet has vents on the trailing edge of the wing in line with the wing. It's pretty neat, pretty aerodynamic that way. Yeah, and go back 1 slide. Tanks must be that one.
Yes, sir. Yeah.
All right, tanks must be interconnected if engine is fed from more than 1 tank at a time. And that's if they're trying to cross feed a different tank. Yeah.
So this is for not only multi-engines, like you were saying earlier, but also for when we just select the fuel, the valve selector to vote.
Yeah, and I think the good example that we had was the old bird we have outside, the 414 of the one that didn't do that. Where they just ran it, you didn't have it interconnected. It was like connected from this tank all the way to this tank, and so you had to pump it here and then come back, and all of us stand around like, what were they thinking? So if I need fuel, Joe, lock in with me. If I have fuel in my locker tank on my nacelle, clogged or damaged, and I can't get fuel in the full 14. 1971, they said I had to pump it to the tip tank from the locker tank. And
The
then
locker
cross,
tank?
yep, right behind the engine, the cell, yep. Pump it to the tip tank, and then pump it from the tip tank to a crossfeed pump all the way over to the right engine. I'm already halfway there, just pump it stinking to the right engine. And so that's what they did with the 1979 with the 414A. They said, hey, if we just pump it to the right engine, it saves a lot of lives.
And, okay, so this requirement right here is to fix what happened there?
Yep.
Okay.
And that's a lot of the regulations. That's why we have regulations.
Right. I'm failing to understand why the importance of interconnecting, like, the tanks, like.
We'll get
that
there.
taught.
Yep, we'll get there. Let's hop in. Let's finish fuel feed, and then we'll get to pump system. Makes sense. Okay? All right, here is our blazing fast Cessna 150. Whoa. Mach speed of what? 90 knots or 100 if you're going straight down. Okay? So, here's our 150. Pretty common to have a gravity fuel-fed system. So, if it was state-of-the-art in 1965, Cessna 150 was designed to last how many years? 15 is correct. Yep. You get the award for today. We'll ask Case to give you a little ice cream voucher or something. Okay, so the way they originally, if you see these little weird straws on top of the wings, those are actually certified for that aircraft, even though they look like they were built somewhere else. I was going to say Alabama, but so the fuel tanks were originally had little bitty spouts here, so as you're going through it, it would create a pressure into the tank, and it could vent out that way. And then they were cross-vented here, and then comes down to a little fuel selector. The original Cessna 150s only had left or right. There was no both setting, like a Piper. Okay? So if one tank got plugged, you should switch over to the other. So now, then they finally came to where you could go to a both. But if you get into a 150, don't be surprised to see a left or a right. Does your dad's have left or right in both? Or do you know? He does, yeah. 150 was probably the most common to run only left or right.
Would that be a fairly simple SDC to make it from just left to right?
Fuel selector?
Yeah.
I don't know.
Switch out the valve.
You have left or right? You don't have both, do you? You don't have both, yeah. It was 150 was the highest. 120s, 140s, 150s all did left or right. Do they make a SCC fuel selector for you?
Yeah, there's kind of a benefit to have not both. Because if you, one of my instructors always taught me, like, even if you have the both options, go ahead and put it in one tank, alternate it every 30 minutes, and then if something were to happen, where you make pilot error, you run out of fuel in one tank, you swap to the other tank, you still got 30 minutes of fuel. Like a stupid proof for fuel reserve, basically.
Okay. So, this is a very basic gravity fuel fed system. Everybody clear? Okay. Yes, ma'am.
I think I'm confusing myself, but the vent thing, how does that work? Because, like, I think this is dumb, but
It's not down. So as you go up in altitude, take off.
yeah,
Okay, what happens to the air outside?
it goes faster, so there's.
Stop. What happens to the atmospheric air with the atmospheric pressure? As you go up in altitude. If I get on top of Mount Everest, can I breathe?
No, it's not.
More dense, less dense? Is it what is it? Less dense. Okay? The atmospheric conditions begin to diminish, right? So will my life if I go up there without oxygen. All right. So the problem is you have just fueled down in the great state of Michigan is 860 feet. 820, what is it, 820 here? Field elevation, 820? All right, let's not talk about that. 820. Then we take off and we go up. Now we're gonna have a higher pressure, it's trapped inside the fuel tank. What's going to happen to our fuel tank? It's not gonna suck.
It's gonna wanna expand.
It's gonna expand. It's called a balloon. You don't want your fuel tank to be a balloon as you go up, okay? So they have it to where it will equalize on the pressure. That makes sense?
Yeah, do they do that for the cabin too, or like for all, even for little planes, or?
If I start that class now,
Yeah.
you won't listen in January.
Oh, I would.
Okay. We pressurize our aircraft. We don't pressurize our fuel, but we pressurize our aircraft to keep you alive. Yeah.
Well, not, like even the small Cessna?
No, we have to put you on oxygen. We have 4 bottles in the top of the 210.
Like every time you go.
If you get above 12,000 feet,
Okay.
12,500, more than 30 minutes. Above 14,000, both pilot and co-pilot have to be on oxygen. Why am I stating these regs? Hey, we're not there yet. Stop. All right, yes.
I mean, wouldn't it be ideal if your fuel tank was a balloon? That way it's more fuel pressure going to the engine.
All right, I'm not flying with him? Yes.
So, if we can draw from both tanks, they need to be connected. So if that fuel selector has both on it, does that fuel selector now meet the requirements by itself?
For the new ones, probably so.
Right. So do we need that little vent on top to meet that requirement? Or
That's
does it-
cross vent is just to make sure that one side doesn't get plugged.
That's not connected at all to that requirement. So
That's
that would
right.
be all connected.
Well,
Right,
there's
okay.
another requirement for that one. Yeah.
Right, okay, thanks.
Cross vent, yeah. All right, so this is the most basic. Everybody got the most basic? Any questions on the most basic gravity feed fuel system? Gravity feed. What feeds it? Gravity. There's no fuel pump. Yes, ma'am.
How do you regulate like the speed that the fuel's coming in? Is that the carburetor?
That is engineered. You just turn it on.
Well, it's just gravity.
We're not talking about power plant. Stop. We're talking about you, the pilot or the mechanic, decide you're going to turn the fuel selector on and start the engine. Do you know how much fuel's flowing? No. It better flow in order to run. And it's engineered to run at a certain rate, minimum of 150%. All right, I'm stopping there. I'm not going to talk about fuel burn yet. Okay. All right, what does it look like on our modern aircraft? Please take a gander at this, okay? You need to pay attention, especially those who are going to be doing labs in my class. So, this is our Lycoming engine here. Your gasculator sits typically about right here, oil cooler here. Sometimes oil cooler's on the back left or the back right of a Lycoming. If it's a chaired key, it'll be on the front left, alternator on the right. So, front of the engine, fine. But you're going to have a gasculator. It could be on the pipers. It's sometimes on the left side from the pilot's perspective. So we're always referring to it from the pilot's perspective. So when I say right side of the firewall, it's on the right side from the pilot's perspective. Remember that? Everybody good? Okay, this is a gasculator. You have this little drain. You have a little bitty nozzle right here with a nut on it. You remove the nut and the bowl comes off, and it looks like this. Just like this. Okay? You can leave the standpipe, you can remove the standpipe, or it's basically just a drain so it doesn't drain onto the airplane. Okay? Remove that nut from the ground looking up. Okay? If you turn it the wrong way, it will crack it. Take that off. This cover will come off. Oftentimes there's a little gasket right here on top. Most of the gaskelators will have a gasket on top. Okay? Pull that off. You do not have to take the housing off the airplane. Everyone understand that? When I say remove this gasculator or strainer for inspection, The expectation is you cut the safety wire, you loosen this nut, and you pull the bowl off so that we can see the screen down in the bottom. It doesn't have a screen, it's just glass, fine. The goal is to remove it and so that we can inspect it to make sure there's no dirt or in this case corrosion. Did I already pass this one around? This is a good example of one that has severe corrosion in it. A lot of water was in this one at some point, okay? Then, listen to me please. When you reinstall the gasculator, you put it on, you torque it down. The torque is only found, write this down, is in a picture of Cessna 1973 through 1963 through 1968 or 68 and after Cessna 172, 182s. If you're using one prior, so Cheddar is working on a 150 from 1965. And he gets in the 65 manual for a 150, and all it says, in great Cessna terms, install and torque gasculator bolt. But it doesn't tell him what torque. Him being a good mechanic says, well, I'll just standard torque that bad boy. And it's going to snap. Okay, it's aluminum. What is acceptable practice? Did I say approved? I said acceptable practice is for you to go to the newer manual and torque it based on what is in that picture. And I will tell you as a hint, it is less than 30 inch-pounds. I'm not telling you this. Anyway, you're going to go to the manual. When you're doing a gasculator, you're going to open the service manual to that aircraft that you're doing, the exact service manual. If it's a 1962, you're going to open the 62 Cessna 172 manual. Over on the right side of your page, you will also need the IPC, okay? Because in the service manual, it's going to have a great line that says, remove gasculator and inspect it. And then when you get to install, it says install in reverse order. I just gave you the whole Cessna manual. There you go. And you're like, well, what am I looking for? So then you go to the IPC. What is IPC? Illustrated Parts Catalog. Illustrated Parts Catalog. And it's going to tell you play by play what's actually in there. And you'll look at it and you'll say, yep, it's clean or it's dirty. And you reinstall it. Okay? When you're safety wiring this one, this is a stinking common fault. Is to safety wire it the wrong direction because you're standing up looking down and you're like, yep, that's the right way. I don't know how many students I've had to cut and say, do it again, do it again, do it again. Because it's got to be safety wired to pull it, to prohibit it from loosening from the ground, okay? But some of you are taller than me, Cheddar, so it's hard for you guys to get down here and look up. Like, yep, is that the right direction? So you got to think, which way is loosening? This is the correct way, okay? As it's going to loosen that way, it's holding it from loosening, okay? There is a pretty common practice that I do not endorse of over-torquing it, safety wiring it, and then loosening it. For the record, I do not endorse that. Please don't get in the habit of over-torquing something and then loosening it a little bit and saying, oh yeah, it's good. Okay.
What's the purpose of them doing that in the first place?
They may not be that great a safety wire.
It makes it look pretty.
It makes it look really pretty, yeah. Right. A pump-fed fuel system, pump-feed fuel system. Any questions on gasculator? It's pretty self-explanatory once you get into it. But what I'm trying to get you to stop doing is pulling these two bolts off the firewall. Okay? That is not expected, really, unless there's something, it's frozen in here or it's gotten damaged. You don't have to pull that. These just basically, one little bolt, or nut, holds it and will remove the whole thing.
Is there a drain on some of the bolt so that we can pull a strainer inside and get fuel out?
Yeah, so you want to make sure the fuel selector's off. That's what the service manual will tell you. Make sure fuel's off, and then drain the bowl into a little bitty cup. much fuel anyway. So a little cup, drain the fuel out of that, and then loosen that, and it'll come off. Just make sure the fuel selector is off. All right, pump feed fuel system. So a couple of highlights here, pump feed fuel system. Give me an aircraft that has a pump feed fuel system. Piper Cherokee. Okay, any others? Archer, DC-3. Aztec does, correct? So very common low wing. Why low wings? You had one? You feel like I shortchanged you?
No, I was just entertained by a comment.
Oh, okay.
Because with the high wing, you have the fuel up, up high.
Yeah.
Go down.
So low wing, the nice thing, the nice ability is someone at my height can fill the fuel system very quickly and inspect the fuel system very quickly without having to crawl on top of the wing. But now we got to get the fuel from here up to here. Okay, so they'll use a pump system. So typically, it'll look more complicated than this on the aircraft, but your wings have your fuel tanks in them. They run to a fuel selector, then down to a strainer. Sometimes it'll run to a strainer and then over to the fuel selector. Some of the newer aircraft even have a sump at the fuel selector. Okay, why would that be such a good practice now? A good standard to add.
So water doesn't get in there and corrode it.
That's right. You don't want it to eat away at your fuel selector. I'm in favor of having a sump at the fuel selector. I like that. So if you're working on an aircraft, does the 172S have that, Mr. Kurt? A sump at the selector? Yes or no? You don't? I know you have 13 sumps on the 172Ss, right? Yeah. Yes. Yes, Amanda.
For gravity fed, would they also have, like the sump at the fuel selector isn't specific to fed, right? You could also have non-gravity fed?
Yeah, they could be on gravity fed, but as I said, most of this is new modern stuff, so it's most of them will have a pump fed system.
So
You could
most
have
of
it on the
the-
gravity, but
Most of the new planes have low wings, is what you're saying?
no, like our 172 is a fuel injected, so it's going to have a pump fed system anyway. Even though it takes gravity to the selector, it still runs a pump to run the engine. Yeah.
The pump system is the gaslighter / strainer still at the lowest point.
Yeah. And sometimes you have two, depending if it's a tail dragger, whatever. Yeah.
You still have to have that regulation of 150% of takeoff power, fuel flow.
No, and I already alluded to that. What was your question?
My question was, the engine-driven fuel pump, even for like a high wing, gravity fed, for a fuel injected engine, are we able to gravity feed to a fuel injected without a pump or no?
Nope.
Okay, so if it's fuel injected, there is a pump.
Yep. I'm trying to come up with a scenario that's fuel injected and gravity fed. But you gotta get fuel on top of your engine. I don't know how you do it. It has to be pump fed. Zachary.
Yes, sir.
So it's going back to engineering now. When you submit a new aircraft to the FAA, you have to have engineering basis for what you're proving. So if you if you're not seeing 150% or 125% systems anymore, that's probably because they're going to highly, computer generated engineering to be able to prove. Okay. All right, so when we get to a pressure feed fuel system, we'll have a fuel pressure gauge. So you go to start the aircraft, you kick a boost pump on, and you're watching for fuel pressure to start, okay? Sometimes it's pretty funny. You'll kick the fuel pump on, and you don't see your fuel pump or your fuel pressure start to move. Oh no, I forgot to turn the fuel selector on. Okay, so then then they turn fuel selector on, and automatically now you're getting fuel pump pressure, okay? Don't, depending on the manufacturer is where your fuel pressure will read from. Sometimes it's here, sometimes fuel pressure reads up here. It's dependent upon the manufacturer. But once fuel begins to flow, the pump will indicate, hey, you have this much pressure. For a Piper Cherokee or Piper Arrow, what pressure are we normally looking at? My Arrow pilots? Yeah, it's usually between 5 and 7 psi. That's about it. Yeah, very low pressure. We're not looking for very high pressure. My Skyhawk pilots or 210s. What type of pressure or how much pressure are we looking at? About 20 psi sometimes. Whoa! Really pump out some pressure, okay? Really pumping pressure. So it's dependent upon manufacturer, okay? You'll get more into that with power plant. Internal leaks can be located by observing the pressure gauge, okay? If my pressure gauge, if I'm running, and all of a sudden falls off, I could have a leak. I could have, when I go to do my ops check, I could have left the gasculator loose or not all the way lined up correctly and start pouring out. And my fuel pressure would only be up to about 5 or 7 psi only for a second, and then all of a sudden fall off. That would tell me I have a leak in the system. Okay? All right. A pump fed system is super nice because it ensures that I have positive flow rate through any maneuver that aircraft was designed for. Okay? Gravity feed, there are times where you could get into a certain stall and then spin where you might lose fuel flow. But versus a pump fed system, I ensure I have a positive flow as long as I've got fuel in there. Right? That's the benefit. It's like nice insurance. Somebody had a thought, idea? Okay. Yes, sir, Zach?
It says engine-driven pumps. Does that mean it just comes on when you put the starter on?
When the engine's running, you have an engine-driven pump, correct?
So you can't pressurize before you turn it.
Ooh, there's a next regulation. So if you have a pump-fed system, you must have a backup pump-fed system that is electrical. That's how we started. And then once the engine begins to spin, the pump will then kick in. I have a pump here. I don't have the pump. I guess it got taken out. I have a pump somewhere. Fuel pumps, engine-driven fuel pumps, once the engine's running. Yep. All right, this is FAR 23.955. Gravity fuel fed or fuel flow rate of gravity fuel system. Main and reserve supply must be 150% of the fuel consumption. If you have your FARs, I don't have the current manual in front of me. I'm curious if this chapter is still in your FAR book. Somebody check me out. If your 2025 or 2026 has this positive flow rate, this is an older number. All right. So a pump system, if it's a pump-fed system, what's the percentage that the FAA says it needs to have? 125%. Okay. Why do they allow a less amount?
There's a 25% less chance of it failing.
Okay. So what does that look like? On the 414, each engine burns 32 gallons an hour per engine at full throttle. I need 125% supplied for each engine. So 125% of 32 gallons needs to be able to be available on the pump fed system through the lines. It means the size of the lines, fuel selector, that aircraft came off. Okay? Off the assembly line with 120% or more. That's the bare minimum. When you get to fluid lines and fittings, you'll say, well, man, I can change this fluid line to a 3/8 instead of a 7/16 fluid line. What's that going to do for my flow rate? It's going to increase the pressure but reduce the volume. It's not legal. You see how this applies now? And so when we get to, you get to brakes, you get to flexible fluid lines, just on the direction that you run your flex lines could change the amount of flow rate, okay? So if it comes through the leading edge, it needs to go back through the leading edge. The full 14, if you look at the left main gear of the full 14, some horrible mechanic decided they would drill a hole through the wing and pull the fluid line or the fuel line right through the main left fuel line through the left main landing gear of the full 14, right over the top of the tire, because it was convenient for them to drill a hole there. Okay? Do I get 125% where they ran it? It's reduced to flow because now it's going back on towards the trailing edge of the wing. It's not a legal change at all. Yes?
Part 23.955, I'm not able to find in part 23.
Okay, I thought they took it out. Yeah. Pretty sure they took it out. This is old style. So, yep.
It says they removed it in 2017.
Okay. So, they're going straight to the engineering. What's the benefit of me knowing this off the top of my head is I work on aircraft all the time. When was our 172S model built? 2002. So I'm working on 2002 aircraft. It was certified under what? 955. I need to, if I'm working on that, and I think I have a question about fuel flow, it was designed to have 125%. I need to know that. See the benefit? It saved our lives. It saved the lives of our pilots in the Citabria because we knew you need to have 150% fuel flow. Saved their lives just by saying, hey, let's check fuel flow. Lo and behold, we know why it shuttered. Yep.
When we get into aircraft manufactured during different eras and different regulations for those eras, how do we navigate that as far as like knowing, hey, this particular aircraft was manufactured under 93.955, this version of that regulation, and then this one is under a different regulation, which is not under a regulation pertaining to this matter.
Sure. Sometimes you could call the manufacturer. They're normally very helpful. Hey, I think I'm having a fuel flow issue with this aircraft. What should my fuel flow be? And they'll tell you about this many gallons. You know, for the Citabria, we didn't have anyone to call, but I did know the reg said, hey, isn't it supposed to be 150%? And that's where we realized we only had 13 gallons instead of 20 gallons.
Okay, so if hypothetically we're in that scenario and we don't know that, hey, there was a reg pertaining to this issue, because there is currently not a reg pertaining to this issue, and then we make a judgment call that, you know, besides this, otherwise from this is perfectly approved or acceptable, and then there's an incident, are we then held liable?
Yeah, because you put your name on the paper. So that's why I said you got to use all available data, or you contact the manufacturer. Okay. Yeah.
And if you contact the manufacturer, you should put that in the maintenance notes.
Oh yeah. Yeah. Based on manufacturer information, they're going to send you information for that. Yeah.
So why then were these taken out?
Because they went back to the engineering. Did I say that? Yeah. Went back to the engineering data. So you have, when you present it got stricter. Basically, you have to present a whole group of data as a manufacturer aircraft to be able to get it certified now for a whole FAA board. Yep. I'm really not covering building aircraft. That's not my, it's for us to maintain aircraft. This is just one of those that if you put it in your file, if you're ever having a fuel issue, put it in your file and say, what was that aircraft approved to run with? fuel system. This is a Piper Cherokee 180. It goes a 3-window unless it's a 65 and prior. 65 and prior was still a 140 horse. But this would be lower fuel tanks here to a fuel selector coming from the Hershey bar wing here. So your fuel tanks are here. Remember, they leak right over your brakes. It's a bad idea. Fuel strainer, and then over to primer, or then engine-driven fuel pump or electric-driven fuel pump. Okay? So your primary, you can boost it this way. They're in parallel. You guys ever heard that term before, parallel versus series? Okay? We do that even in fuel systems. Okay? All right. So parallel system. Why is it important that they're in parallel? In case one fails, it will still feed the engine. Good. Good. Pipers are notorious for having no both. It's left or right or off. Okay? They're also notorious for fuel selector failures. There's a plethora of ADs for fuel selector failures on Piper. I will recommend you read the NTSB reports. Please don't go to pilot or Piper owners, AOPA Piper owners. They don't have very good things to say about fuel selectors. Okay. High wing aircraft for fuel injected combines gravity flow with the use of fuel pumps, aka 172. Fuel is pressurized by the engine fuel pump, metered as a function of the engine RPM. So, this is kind of getting into power plant, and I'm sorry for that. Fuel pumps on the engine, are they constant displacement or variable displacement? What'd you say? What'd you say? Variable. Okay, who's right? But they're constant based on RPM. The engine varies, but they put out the same. They won't vary based on pressure. They vary based on RPM. So it is a constant means it's just going to go. But it changes based on RPM. A variable pump, there are variable pumps. We use them in landing gear and hydraulics, where all of a sudden it senses, ooh, this much pressure, it will slow down. Ooh, we only need a little bit more pressure, then the pump slows down on its own. That's called a variable displacement. The engine-driven pumps do vary pressure based on RPM, but they are a constant displacement pump. All right. So we have a fuel flow indicator tapped off the distribution manifold. Distribution manifold has multiple names. Once again, Clayton Bradley, why did we give multiple names for fuel distribution manifolds?
Because they hate us.
Because they hate us. So they are called spiders, they're called fuel flow dividers, they're called flow dividers. They're all the same thing. Yes?
Me?
Yeah.
I missed what TCM stands for.
Teledyne Continental Motors,
Thank you.
even though they work on engines. I don't, tomato, tomato, potato, potato. No, it's different. We don't work, they work on engines.
It's because they hate us.
It's, it is, okay. Actually, I think it was they were trying to sales pitch, and then whoever came up with a slogan or the name didn't know the difference between a motor and an engine. But you do. You're a good mechanic. All right, here's it. This is MAF. MAF. Ripping some landing gear off 206s here just for good times. All right, I have a high wing with a fuel injection system here. So notice here we have a vent. We have probably cross-vented, I don't know on this 206, but then we ran to an accumulator tank here even further down. We have accumulator tanks here. From there, then they go to the fuel selector, electric pump, can go to strainer, engine-driven fuel pump, and then fuel injection manifold. Okay? It is a high wing gravity fuel fed system that is a pump system.
Did you go over what a accumulator tank is for? Like, what's the purpose of it?
So, accumulator tank, is oftentimes at a lower spot, could be even underneath the cockpit floor, just for variable maneuvers to maintain fuel flow. Okay, sometimes it's high attitude, you come in, high attitude landing, you still want fuel flow. It's a good spot to have positive fuel flow. And so it can still pull from that. The accumulator tanks, not always, but they're usually less than 2 or 3 gallons at a time. Bigger aircraft may have bigger fuel tank accumulator, but it's usually at a lower portion than the engine, so the engine can pull that in an unusual attitude. Stall, you're stalling, you're doing maneuvers, and you stall it, and you kick it over, and all of a sudden you lost fuel flow, but it can pull some accumulator. A stall doesn't normally last 2 or 3 gallons.
I guess I'm wondering, how does it being lower help that pull? Is it pressurized?
It's because your fuel pump is typically at a lower place to be able to pull the fuel.
Okay, so it's,
Yep.
Why are the pumps in series?
Sir?
Why are the two pumps?
I don't know if it's actually in a series system on this particular one or not.
Okay.
I'd have to look. It may just be an engineer's drawing of something that they're trying to explain. It may not be. Just remember that. They're not always accurate, especially Cessna. Okay. Each tank must have 2 vents. This is not always, but now it is. A lot of the newer aircraft. Each tank must have 2 vents arranged, because if one vent gets plugged, you have a way to still allow the fuel in the tank to equalize with atmospheric conditions. All right. If Joe takes off from Mount Denali, that's Alaska, okay, and you're flying towards Anchorage, Mount Denali is what, 9,000? Is it 20,000? Is it that high? Okay, so Mount Denali is, you're taking off 20,000 feet, you're going to land at Anchorage. Anchorage is how high? All right. You're going to have a problem because now you have fueled up, okay, and the flight from Denali to Anchorage may not be that long. It's pretty quick little flight, about an hour and a half or so.
Especially since we're going mostly downhill.
Sure. All right, so then you take off. If your vents are plugged, what's going to happen to his aircraft? What's going to happen to the fuel tanks, rather? It's going to crumble. They're going to implode. Why are they going to implode?
Because pressure is getting.
Because he fueled up at a lower density altitude, or the outside atmospheric pressure was lower, and then he's going to go to a high pressure and land. And Denali to Anchorage, is it an hour and 20 minutes? It's not that far.
It's probably not an issue because I could probably just glide from
Okay.
Denali to Anchorage.
All right, I'm trying to give, don't confuse us here. Let's stay on target, because this is a real life application here. Okay, so you take off. Maybe you're at Port Allsworth, or you're going to fly from Denali to Port Allsworth. Okay, all those are very low altitudes. You have the chance to implode a fuel tank if your vents are clogged. Okay, does that make sense? Minus all the other. Realistically, that is a real fear. Okay, where the tank could implode if our vents are clogged. Okay, yes.
Is there such thing as like a vented cap?
Yes. Yes. We have vented caps now, yes. And now we're putting them on each side is our goal. Yes, let me get Joe, and I'll get you, Jim. Okay, yep.
Your application of why we have vents does make a lot of sense. But what I had always heard was, hypothetically, even if we're just staying on the airfield, like we're only taxiing, if all the vents were to get clogged, we would no longer be able to pull fuel out of the tank. Even if the pressure outside was the same, that being irrelevant.
Good.
We're not going to be able to pull out because now we're pulling a vacuum in the tank itself.
Potentially pull a vacuum in the tank. Yeah.
Well, if we don't have a vent, then we would have to.
Your comment gets a little tricky when you get to high wing or low wing, where the fuel's pulling
saying on 172.
I'm afraid we're gonna confuse folks if we try to get in this scenario right now.
Okay.
Do you understand the purpose of vents, though? That's what my goal is. Do you understand venting, why we vent? Why we're doing redundancy? Because older aircraft, you'll even still run into, does yours only have, you only have one vent on the right and one vent on the left wing still. Your left cap is not vented, or did you buy the new?
Just both caps,
You bought both caps.
but I think
So-
it's original, I don't think there's another separate one.
Okay, so say you're working on an aircraft. Israel's working on a 150, and he has to replace a fuel cap. Can he replace it with a newer style fuel cap? You said it. STC or an AD that references a service bulletin, which there is. So my recommendation is that you would put the new vented fuel cap on, okay? Does that make sense? Because you've already read the NTSB reports of fuel vent failures. It's a very serious thing, isn't it? Where a fuel vent gets clogged, and now we couldn't get enough fuel in an unusual attitude. Those of you who are not here, that lab is open.
So is this a blanket rule, both the engines, every tank has to have fuel vents? Is that kind of across
Just
the board?
about,
Okay.
yeah. I can think of several aircraft, older aircraft that are not, but newer aircraft, yeah, they're gonna be multi-vented, yeah.
And the cross vent wouldn't count.
Does count sometimes, yep. Yep. Depending on where the fuel tank is, yeah.
So, I think what I'm catching up on is, all systems have a pump at some point, or are
Not,
there?
not all systems have
Okay.
pumps.
So.
The 150 didn't have a pump.
Okay, so then, like Joe was kind of saying, if it's not vented, or vents get clogged, then it's like you're holding the top of a straw.
That's it.
The water's not gonna come out.
Yeah, it could act as a siphon on, especially on a gravity feed system, it could act as a straw. If your vent is clogged, your vents are clogged, it could act as a straw and not allow a gravity system through the gascolator to actually get fuel. Yep. All right. Do you have your hand up? Yep.
Is there a reason we don't just put two separate vents in the cap?
You usually want one coming on a different, so what they typically, Cessna's doing now is they'll do one on the back of the tank and then one on the cap. Piper does the same thing. They'll do one at two different areas. That way if one gets clogged from dirt, or damaged, then the other one won't, yep.
What keeps water from entering those vents or the
The direction that they are. And sometimes there's a check valve on them to where when they get to a certain pressure, then it opens. Could water enter? Yes. But typically you have air flowing over it, it's gonna open it. Or the vents on the back. If it's the old style like this, you get water in for sure. For sure.
Why are you doing the check valve in there? Because you wanna release pressure and
Yep.
you wanna
Yep.
suck pressure in.
Yep.
Check valve
I'm
is one
trying to
way.
think of some aircraft will have a vent like this and then right behind it will have a water drain there. So as it comes through, and if it has water, it just drains off so they can vent to the tank itself. Okay, here's a vented system. It didn't show you cross vent. It's funny, they don't have a cross vent, it's cross feed. This one goes here. But it should have a vent here and a vent here or a vented cap. Because right now, this is not even showing a fuel cap. It's kind of funny. Like, you look at some of these drawings in your book, it's like, did somebody think through that? So, but I think that what they're highlighting here is you'll have two different strainers, because you have two different engines. Okay? One of the FA questions, how many vents? How many vents arranged so that they're not likely to become plugged at any time or at the same time on a multi-engine aircraft? What's the minimum vents 14, Old Bird, Notorious, has 3 tanks per wing. Okay? Then it has a cross-feed fuel tank. You guys take a break. Come back at 22. Come back at 22. No, wait. All right. Hey, I'm going to start back, okay?
We're like 10 minutes.
Hey, guys, I'm not waiting on anyone else. I'm going to start. Okay? All right, so transport-type aircraft fuel system typically contain more redundancy and numerous fuel management options. So just like you saw in the video of the Airbus, right? The video, Mayday video. There was numerous redundancy over and over again on fuel calculations. But even still, the co-pilot had to do the fuel calculation in that Mayday video. Why was that so important? Why did the co-pilot or first officer still do the fuel calculation?
Make sure your numbers are right.
Yeah, who plugs in the numbers? Yeah, every time you fuel an aircraft, who plugs in the little numbers on the data? The pilot does. Yep. Okay, so other features. We have an onboard APU, and just like the APUs on trucks and on RVs, they run from the same diesel fuel tank, or sometimes they'll have their own fuel tank system, APUs will. In aircraft, our APUs run on the same jet fuel, okay? Makes it highly convenient, but also a little bit more sophisticated for us because we're having to double check ourselves. Why is that? It causes us as mechanics to have more checks. Why is that? Why do we need have more checks? Logically. Safety. We have a fuel leak even around the APU system when it's not in use and we're flying up. Man, we could have the danger of leaking all of our fuel through the APU system. Okay? Same thing happens on a reciprocating aircraft. We use combustion heaters that run avgas in our aircraft. So on a multi-engine aircraft, Aztecs, 414s, 421s, they have a combustion heater in the front. It runs avgas. If there's a leak, the front of the airplane is going to blow up. Okay? Because the moment that avgas ignites, it's right beside the oxygen bottle. You'll see numerous NTSB reports where the whole front of the aircraft blows off. Okay? So when we're talking about fuel systems, even our heating system is part connected because it's running from the fuel system. It's running from avgas, or in this case, from jet fuel. So it causes us to double check ourselves. Is it connected correctly? Is there any blue residue? Okay? Fuel jettison. What is fuel jettison again? Yes.
I'm not answering your question, I'm asking a question.
Okay, hold on before. I'm asking the question now. Yes.
Dumping fuel.
Dumping fuel. What is the key purpose of dumping the fuel? To get to a safe landing weight. Good. That is an FAA written question. I just gave it to you. You all pass your airframe. No, good. Yes.
Why were you saying blue residue for jet? Don't they use jet engine?
They use jet. If it's using like I was thinking of the combustion heater, blue residue for avgas. Yep. But for fuel systems for APUs or heating systems, we'll use jet fuel. Yep. Single subsystems underneath the jet category. We have fuel storage. Sometimes we call them the trunk tanks. We call them nacelle tanks. Nacelle tanks, where do you think the fuel tanks for nacelles are? Behind the engines. Good. They're called nacelle tanks. Those are on the King Air, you have nacelle tanks. Unfortunately, they did not use logic when they wrote the manual for the King Air, and so they did a total amount of the fuel. And those of you on the King Air, they'll do a total amount for each wing. But you have 2 tanks, so you have to do the math. Yes?
I did see that each nacelle tank, it does have 57 gallons of usable. It does say it on the manual. Does that help?
It helps you,
Okay.
but then you have to subtract the nacelle tanks when you get there, yep.
Okay.
All right, so then subsystem storage, how we store it, vent, how are they vented? If it's in the back of the beach jet, guess what, it's still vented. Why do you think the baggage always smells like jet fuel back there? Okay, it's vented. And then distribution, how does it distribute it? Do we have to pump it all the way to the tip tank? Do we have to pump it from the locker tank to the left engine or to the left fuel wing and then back over to the right? I don't know what some of these engineers think sometimes. And then how do we feed the system? Let me get this. And then indicating, okay? Is it a digital? Is it the capacitance type? Is it this funny, cute type like this? That feels like Henry Ford design, right? They still work. You notice we didn't go to the new GM style because they failed. Hey, I'm picking on GM today. You happy? Okay. You know, we use the old Henry Ford style that still reads the indicator. Oh, there we go. And it's resistance. Okay? Piper did not follow Cessna. So whatever Cessna, if Cessna reads resistance on empty, Piper reads it on full. They're backwards. So that way you can't use a Piper on a Cessna. You like that, don't you? Yeah, that way they make sure they can fill their pockets at night too. Okay? Yes. You had a question?
Yeah, what were you saying was vented, a baggage compartment?
The trunk tank. So in the beach jet, right in front of the baggage is a giant fuel tank. And it's vented somewhere above the baggage there. Because you always smell it when you get in the stinking baggage compartment of the beach jet. It's always venting right there somewhere.
Like, I thought the vents were venting like to the outside.
It is. And what will happen is there's some vents on the back of the beach jet. Eventually, as you're going through the air, it will make its way there. But it always stinks in that baggage compartment.
On the single point pressure fueling, I was told that if you're fueling while the plane's running and your pump sucks air, pushes air in there, it can cause air to go to the FCU, to the engine. Is that true? And if so, why?
I don't know. I have heard that one other time. I can neither confirm nor deny. But I think it's worth looking into for sure. Like a hydrolock or vapor lock. Yeah. Yep, Dave.
Is there anything we didn't cover on this slide before this highway went?
Did I skip something, buddy?
I think before we went to the break, we didn't cover it.
This one?
Yeah, I didn't know if there was anything else right now.
You have 2 fuel selectors. You can see that they can pull from, each selector can pull from either side. You have a strainer for each side. You have a flow divider for each side, servo for each side, and then the spider. About it. All right, indicating, I already covered that. Storage, all tanks must be fueled through one connection. That is on what type though? Hold on. If they're filled through one spot, what's that called? Single point. Man, such a blessing to be able to use single point fueling and defueling. At some point, you all will defuel aircraft in your aviation career. Given. You know, one aircraft, I'm trying to remember what aircraft it is. Maybe it's a B-200 King Air. But I'm not quite sure. We have to fill the tanks, fill the oil reservoir, all the way up on the jet engines and fill all the fuel tanks to do a gross weight analysis. And then to be able to do a useful load check. So every, I don't know if it's every couple years or so, you have to fill it all the way up. So what do you do with the fuel when you're done? You gotta drain some of it. You gotta put it somewhere. So you have to drain sometimes hundreds of gallons, or the pilot has to go out and fly it, which they also enjoy too. Okay. There are multiple configuration options. It's just a nice way for me to say they're hooked up however the manufacturer figured it out. You know, there's no rhyme or reason. Okay? Venting must be configured to ensure fuel is vented regardless of the attitude of the aircraft. Okay, whatever maneuver. Distribution, any engine should be fed from any tank. All engines can be fed from all tanks simultaneously. This is not historically, and I told you the beach jet, you could not run, I guess it's the right tank from the trunk tank. Until Beach changed that.
Right, good question. So for that airplane, since it was, are there ADs then on that to change it?
Nope,
Okay.
nope, it was how it was certified.
Yeah, so it doesn't have to
That's right, it does not have to conform to the new standard, correct. All right, and then as we saw in our Mayday video, those of you who missed it, I'm sorry, but Mayday video, a damaged fuel tank should be isolated and not just cross-fed the whole time. What do you call that? A glider. All right.
That's a stupid thing.
I was calling it a glider. It's the largest glide ever. Largest, longest glide. It's sure it's just a computer. All right. So jet transport aircraft systems. The point that I'm pointing out here, David, are we locked in here? We have surge tanks on these jets. What's the purpose of a surge tank? Expansion tank and? Go ahead. Say it, Swift. Turbulent air. Yes. We don't want the fuel to be sloshing over the vents. We want it to go to a surge tank. So a surge tank oftentimes has a galley about like this. So a vent's teeny tiny, about that big. Usually about the size of my pinky. But a surge tank will have a galley at the top. So here's my fuel tank. Here, as I'm filling it up, it'll show full about here. And then right towards the external portion of the wing, outboard portion of the wing, will be two little galleys. So if it sloshes, it'll go over that and into the surge tank. Okay?
Is the surge tank also where fuel will pour out if you overfill? Or is that a different system?
Yeah, it goes back to manufacturer, but yeah, oftentimes it will, if you overfill.
Overfill surge tank?
Yeah. A lot of times, like the beach jet, it'll come out the filler head. It'll actually come out the filler top before it comes out the surge tank. Yeah.
So if it's sloshing over to the surge tank, then you're losing.
No, you'll be able to, it'll actually allow it to come back in. As the fuel comes down, it'll come back into the main tank, yeah. Yeah, let's not say that. I think, yeah, let's not say check it. No. It's way more simple than a check valve, because I think about check valves in plumbing, Mr. Plumber, they always fail. Okay. Oh. That could be that way, but no.
So then, are you also flooding your surge tanks whenever you turn? Like, one surge tank?
Sometimes, yeah, and that's why they have to be able to feed back into the main tank, yeah. You know, if it was in Georgia, we'd call it a slosh tank. But it doesn't sound very nice. Yes?
Why didn't they just make the tank larger? Don't have to worry about. So you got.
Because your fuel's gonna move. How much does a 787 move? How much the wing? 38 feet of movement. Fuel's gonna move, and if you're pushing how many gallons of fuel? 45,000 gallons of fuel, it's gonna move. So we want to be able to give it a buffer. And probably the reason why we have a surge tank is because aircraft that were designed without it may have cracked some of the ribs or spar or even some of the skin. Yeah.
What keeps fuel from going from one tank to the other through the, like, I mean, I know some will, but say you're
Some
in a
will,
turn,
but-
but what keeps your fuel from draining?
Sometimes check valve, that, the 414, 414 that you read that had the crash, they didn't hook up the valve correctly or nothing. Did they leave it out? They left it out, didn't they? The NTSB report that you guys had to write up?
Yeah.
Did he not hook it back up, or did he hook it up incorrectly? The reverse flow, that's right, yeah. He left it totally out. Yeah, so then when he went to the turn for final, it went to one wing and did not. If he would've turned the other way, he would've come right back, but he didn't think. He was just maintaining. Yeah, that's what it was. When he turned, all the fuel went to one side, that's right, reverse flow.
He was a little, compromised.
He was compromised, inebriated, yeah. So distribution of subsystems gets highly complicated, okay? I'm just showing you a picture. I'm not going to explain this, David. But they get extremely complicated where lots of sensors, pressure fueling, defueling, transfer fuel system, and fuel jettisons. All right, here's a picture of a pressure point, single point. All right, FAA question. What flight safety related advantage does a pressure point fueling system provide?
What are the options?
I'm not giving you options.
Helps with contamination.
Reducing contamination. Oh, okay, good. All right. Second question, pressure fueling of aircraft is usually accomplished through how many points? Usually one, at least one. That's the actual FAA question answer. Usually one. You like that one? All right. Before fueling an aircraft by using pressure fueling method, what important precautions should be observed? Carter.
Wait, repeat the question.
Okay. Before fueling an aircraft using pressure fueling method, single point fueling method, what important precautions should be observed?
I'm gonna say ground it, but I feel like that's practice.
That's a given, all right? What's the second step then?
I don't know, it's been so long since I flew with him. I don't even know.
Oh, Marcy wants to take a chance at it, shot at it.
Don't you have to know like what the max pressure is for that?
Yes! Max fueling pressure, perfect, yay, all right. All right. Oh, yeah, hey, well, ask Case for your free ice cream, okay. On a large aircraft pressure refueling system, a pressure refueling reciprocal or control panel will permit one person to fuel or defuel any or all fuel tanks of aircraft. Okay, is that true or false?
Would you mind repeating the question?
A large aircraft pressure refueling system, a pressure refueling receptacle and control panel will permit one person to fuel or defuel any or all fuel tanks of an aircraft. True or false? True is correct. Hey, Carter's on it. Hey. All right, kind of already beat this one up a little bit. Allows engines to run. Okay. Always consult manufacturer's manuals for fuel system. Thomas, where were your fuel tanks located in your helicopter? Okay, good. On a Bell type helicopter, where are the fuel tanks located?
On the bell, I'm not sure.
Sometimes they're right behind you, sometimes they're right below the engine, sometimes you have auxiliary fuel tanks, even a part of your seats, okay? Even a part of the seats. So typically, you'll have only one or two fuel tanks located near the center of gravity. Usually a larger fuel tank, so keep that in mind as well. Fundamentally, there's little difference from a helicopter fuel system and a fixed wing fuel system, okay? Fundamentally. But if you look at our Bell, the Bell 206, we have large, they're 20-gallon fuel tanks underneath the rear bench. And then they're routed back to the back of the aircraft and then sent up to the Allison engine at the top too. And they are a pump system as well, because your engine's above you. You need a pump to get it up there.
A diaphragm pump?
Sometimes diaphragm, yeah, sometimes electronic pump, yeah.
Probably drain those pretty fast. It's 20 gallon,
Oh, yeah.
for sure.
Thirsty dogs, yeah. All right, helicopter fuel system here. You have a giant tank. Okay. Here's a better picture of it from a different view that's I liked a little better. Okay. You have to get a fuel pump it to the top, and then distribute it. Yes, sir, Zachary?
In this case, you don't have a gascolator.
They'll have a filter. They'll have a filter. They'll have two different types of filters. Sometimes a gascolator on the back. I'm trying to think. The Robinson does. 66s do. 44 does, of course. All right. Rules for the road. Last slide. Maintain fuel strainer is at our main fuel strainer is usually at the lowest point in the fuel system to trap water. Okay, that's just a standard. If you see a strainer, it's at the lowest portion of a fuel tank or a fuel system. Okay, when I say fuel tank, the Beach Jet has one on the belly from the trunk tank. It's the lowest point. Okay, if there's one on the lowest portion of the wings, or there might be the lowest portion of the fuselage, because they go, there's a fuselage tank as well. All fuel tanks must be vented to limit pressure differential between the tank and the atmosphere, so it doesn't explode or implode. Fuel system components must be bonded and grounded to drain off static charges. Okay? Today, when you're removing a fuel tank, tomorrow really, today you get started, but I want the aircraft grounded. For what reasons? Because there's vapor still in the tank or in the fuel system, okay? So make sure the aircraft is grounded or bonded. I think Case is married to the term bonded, so we'll use the term bonded, okay? All right. Fuel system components must be bonded and grounded to drain off. Okay. Systems must minimize risk of fuel vapors igniting by lightning. So what do we use on our aircraft? Static wicks. And then our tanks are bonded. Those of you on the Cherokee 140, when you remove the fuel tank, do not give it a yank. There's a vent that's still connected that you cannot see, and there's a bonding strap that's connected. Okay? If you destroy it, you fix it. Okay? That's my rule. Right. Rigid fuel lines should have at least one bend between fittings, allowing for misalignment. Okay? They'll be slightly off. Please don't bend them anymore. They have a manufactured bend. Don't bend them more. If it doesn't come off gently, please take another look. Okay? Any questions? I want to hit something really quickly. Those of you removing fuel tank. This is FAA approved. When you buy a fuel tank, you spend $4,000 or $5,000, you buy a fuel tank for a customer. They're going to send you this tape right here. This is a very expensive roll of non-duct tape. This is fabric tape, okay? It's very thick. What we do with it, we'll tape the opening, because you have to get a 30 or 40 or sometimes 50-gallon fuel tank out of a hole about this size, okay? So you go around, you get all of your clips undone, you get your vents unhooked, you get your sump removed, because if you're pulling on it, it's going to bust the wing. Then you tape off the opening the best you can. For our purposes, you're going to use masking tape, because this roll is like 75 bucks. Okay? This is mine. I'm not giving it away. So, I don't use it on an airplane at the house. But tape around the opening, okay? And then on the inside of the tank at every corner, I was always taught to tape the corners inside the fuel tank. Why is that? Why tape the corners?
Weakest point.
Yes, because the rubber bladders will rub as it begins to fill up. They'll rub right in the corners there. And there could be sharp edges. So we always taped here and here on both sides to make sure the corners would never get rubbed. Okay? So we did the opening, and that's what I want to see with my eyes as I'm grading you. I want to see the openings taped up before you rip in the bladder tank out. And then you remove the old tape. That's after the bladder's out, you remove the old tape, and then take a little alcohol and clean that residue off, or you could use acetone. Either one's fine. And then apply new tape once it's dry.
Are you taking the corners of the bladder or the corners
Of the aluminum.
how are you getting in there?
So, God made different people different heights. And some have longer arms than I do. So, at that moment is where I contact someone like Cheddar who can reach to the end of that fuel tank and use it. Now, I have been known to take a sand hammer and stretch the tape out as I get it to the end with a rubber sand hammer, not a wood, not a metal, but use a plastic or a sand hammer, dead blow. And you could stretch out the tape in the corners like that, but highly advantageous.
So this
Yes.
is also the same hole that you're pulling the bladder out?
Oh yeah. Hey, but was it Noah? You know Noah? He called me. He's like, hey man, I'm the new guy on the job, and they said, hey, anybody ever done a bladder? He's like, I was the only one. Raised my hand. I said, yeah, I've done a bladder. It was straight out of school, so. Yeah. Right? Anybody? You had a question, comment? That's
I
useful
think-
for us.
I think you answered it.
Okay.
It was Sam.
Okay. All right. So for this lab, I have several things I want to go over. I'm going to open the labs for you on Moodle. Okay? You're assigned to a fuel tank. When you do a fuel tank, there's also part of the lab. Listen to me. Read the Moodle lab. Because during removing a fuel tank, you'll have to remove a fuel sump drain, which you're also required to inspect and reinstall. If it's dirty, clean it. Don't get done with it and say, oh man, I didn't inspect the sump. It's not my problem, it's yours. Okay? You'll also have to inspect the fuel cap. Okay? Read the lab. If you're touching it, inspect it. Okay? So, grades that I'll be giving, I have a page for fuel tanks, fuel valves, strainers and gasculators, they're the same thing. Fuel caps and sumps. We're going to cover those. And the reason why we start this early in the class is this is only 7 days remaining before our final. Okay? You have 7 days until the final for this class. It's probably 70% hands-on class. So it's extremely busy. You will have a quiz Wednesday. We'll do a Kahoot tomorrow if I can get everything working, just for practice, but then you'll have a quiz on Wednesday regarding the material we covered Tuesday and today and tomorrow. Okay? Yes, Joe?
So you said there's 3 labs total?
No, there's lots of labs.
Okay. And then is the quiz going to be primarily prepware or just classroom material?
My quizzes are usually short essays
Okay.
on material that I've covered.
Yes, sir.
My finals are majority prepped work. And I do that as a gauge to how well I'm explaining stuff. That way I can pick it up before you get to the final. Figure by the final you should have the information. And your quizzes usually tell me if I've taught it or not. That's the reason why I do it that way. I realize some others do it other ways, fine, whatever. This seems to work for me as an instructor because it helps me. If I miss something, I recover it. And it doesn't hurt your grade. All right, I am opening the lab, and then I'm going to cut you loose. What I'd like for you to do is research the aircraft that you're assigned to before you start ripping stuff off. What's the number one tool, or number two tool? Tell me what number one tool that you have in your toolbox is. Okay.
Manuals?
Maybe we should use our brain, but what's the number one tool we have first?
Maintenance manual.
You have your maintenance manual, then what do you have?
Phillips screwdriver.
Your contact list, and on your contact list in your hand is a camera. Take pictures. Take pictures. Take pictures. You won't always remember, okay? Take pictures. The escalator was this way, it was this orientation, the safety wire was here, okay?
What does Apache RTIN mean? IN, right tank, IN?
The inboard,
Okay.
inboard, outboard, inboard, outboard. So you got the right, so you have Cherokee left tank, Cherokee right tank, Apache right outboard, Apache left outboard. Okay, and they're two different sizes. This will be kind of cumbersome with 4 people on the airplane at one time, trying to get their arms inside the wings and stuff. All righty. Yes?
The 150 that we're doing valves on,
Yep.
what is that? Where,
It's out there. It's the one, wood prop one, that somebody did not reconnect the fuel selector on that I'm still salty about.
oh, just that we.
That one, yep. So before you remove a fuel selector, let me just say it across the board because Cessna does not say this. You have to make sure there's no fuel in the tank. And if there is fuel in the tank, you have to do one of two things. You either have to drain the tank or you have to be fast enough to plug it. Because it's going to be a 3/8 line coming down. So it's going to bring lots of fuel, okay? And I may have to say this for some of you. Please wear gloves. There, yeah.
So I know in other industries, they'll use like hose clamps that'll clamp the hose. Are we allowed?
I did not hear that.
That would be a no.
Hey, you crane operators work on a whole different level. I didn't say higher or lower, but I'm just saying. All right, so lab 2, lab 3 is open. And Joe, if you'll look at the syllabus, I have 8 labs for this class. But lab 2 and lab 3 is open. All right, you guys are dismissed out to the lab. Okay, start researching. Grab your books. Grab your IPC. Grab a cart. Yep, we may have to share carts depending on who can access
What
them.
tank are we working with? Is it around 25, 40, 25?
That's what I was telling you is the fun. Go look at your aircraft. Go look at your aircraft. Go look at your aircraft.
Is there only one tank on the right side?
There's 2. You have to do that.
You
You may have to take your shoes, socks, and shoes off. No, you only have one. Do not touch the nacelle tank. Do not, hey, King Air, Cheddar, Corbin, do not touch the nacelle tank. It has fuel. What tools are you gonna need? How in the world are you gonna get up that high in the air?
Like there were 4 interconnected. Let's go.
hey, guys, if you're gonna miss, this is not the week to miss, because making up a fuel tank really stinks by yourself.
Okay, so
I'm not gonna penalize somebody because the partner's not here. Hey, before you get started, you may wanna take a real good look at the IPC.
Alright, I'll meet you guys.
Service manual doesn't have it. It's an
I have a new manual in there. Which one are you in? There's 4 in that, four, right?
Are we looking at the ICC or the maintenance manual?
Yes.
The maintenance manual didn't have very good much.
It's not gonna be in depth, but it will be, make sure you're on the full 14 and not full 14 alpha. Hey, make sure you're in the 70 through 85.
Yeah.
That's the one, yep. 70 through 85, and then the revision 1982 IPC.
Okay.
What's up, buddy?
I am gonna be missing the 10th and 11th. The 10th was final day.
Okay. What's up, buddy?
We're draining the tanks, that's the first step.
If there's fuel in
If
them,
there's
yeah.
fuel in it.
What are you
Assuming there
working on?
is, the Cherokee, I assume there's fuel in there. Maybe there's not, but if there is, bucket, like,
I gotta ask
Get
Nick
with
how he
that.
wants to do this.
yeah, okay. I'll go
We
check
can
the
go,
pieces.
we can go look and see how much fuel there even is.
Yeah,
I assume somebody's gonna need to drain.
you're gonna have to drain fuel, yeah.
Right.
Because, but if there's just a little bit, then we're not worried about it.
Right.
But now we're in a dilemma where we can't put all the